Hello guys, today we're going to do a different video. It's going to be about a company implementing eSCADA systems into a data center facility. And before we spend much more time, let's get into it. You already know, as you already know, I took this from a video and I will put the video link below this so you guys can actually use the main source as your own. And this is a small explanation of how the video goes. So before we spend much more time, let's get into it. Data center. System architecture. The four critical layers of data center management. APMS, Electrical Power Monitoring System. The core subject of it all. It monitors the electrical infrastructure from the utility down to the rack, as in like how everything is moving from the electrical infrastructure. It means how let's say the generators or the UPS, how the general systems are moving with them, and how that electrical power is moving around. We already know how all of this works as engineers, but these are the systems that actually control it. BMS, Building Management System, manages the mechanical side, including environmental controls, chilled water systems, and dampers. As it says, mainly the chilled water systems are extremely important. Well, obviously, other ones are also. But environmental controls, the heat variance, how the wind is moving, how the water is, how much toxicity there is in there, and such and such. These are all controlled by the BMS. Facility systems, independent specialized systems like fire alarm, security, and weather stations. These are basic systems that go on and about how the systems that are different from each other move. Like the fire alarms need to still work even if there is no electricity, or security is a different branch of an entire thing, like cameras, people, and such, or weather stations, how the weather is. DCIM. I explained in a previous video about. Let's get into it again. The Center Infrastructure Management, an asset management tool that tracks every physical component, server switches, patch panels, and their interconnection cabling. It maps exactly which server plugs into which power strip, allowing allowing operators to predict which servers will go down if a specific power distribution unit fails, or how they will move corresponding to with each other. And if you can parallel work them, let's say divide workload between them and such, this is the main controlling unit of that. Sorry, let's see. Okay, there's no problem. Project specifics. As I said, I took this from a video that an actual company made this, so they're project specifics. Capacity, 1.25 megawatts of power with redundant utilities A and B sites, redundant generators, and paralleling switchgear. So it is basically saying that the system must kind of be spotless, in a sense that it shouldn't fail. We do not want this to fail. Scale, initially installed with 36 racks, with space expanded for another 36, so it's 72 in total. Hardware integration and network architecture. The project required integrating a diverse mix of legacy and modern equipment. Necessitating various protocol conversions. So it's basically saying how you need to integrate the hardware and the network, how they need to be connected with each other, and that shouldn't be a problem with it. Like the mix of legacy and modern equipment, that shouldn't be a problem with the old and the new equipment having a problem with each other, and you should move on from that. Generators, Caterpillar. These use serial communication requiring Modbus serial to Ethernet gateways. A challenge arose because the fuel tanks had low high level switches but no volume indicators, requiring ROVs to install fuel gauges, and calculate gallon values via PLC. So it's saying, oh, there is a problem with the generators and they need an additional piece of technology to put inside that. ROVs is the company that is actually doing this, by the way. As I was gonna put the video, you could see it there. And the fuel gogs they're basically for the calculate gallon values. That means the generator itself didn't have that initially, so they had to fix that problem. UPS models, Liber. These were modern and Ethernet ready out of the box. It is basically saying the UPS models that were bought from the Liber company, they were already really pretty modern and they were Ethernet ready. That means they're really easy to set up and use. So there was, or there won't be a problem if we were to use them. Let's check if okay, the record is still going. We don't want to have a problem with that. Output distribution. The switch is controlling the battery power used dry contacts. A PLC was installed to convert these digital I/O signals into network data. Sorry. They were saying how a PLC was used to turn these signals into network data that could be used inside the system because we want an eSCADA. So obviously, I/O signals will not do. 1 signals will not do. So how these switches controlling the battery power specifically, dry contacts. Oh, they were talking about that. EPMS cabinets, custom wall-mounted cabinets that were built to house switches, fiber models, and media converters, acting as the physical aggregation points for the data collection. I would saying physical. It is basically saying that these cabinets are where all of that physical, the data is where all they are connected, and how they are all put inside that specific cabinet, so you could access everything at any time you want, and it's easier to do that. Software integration challenges. As the video was saying, there are some challenges. The Modbus standard issue. While Modbus is a standard, every vendor implements it differently, customizing the ETAP driver for each unique device. Sorry. Modbus standard issue. While the Modbus is a standard, every vendor implements it differently, customizing the ETAP driver for each unique device, swapping bits, handling string lengths, time consuming. A specific bug involved generator temperatures being reported in Kelvin, requiring conversion logic. So let's say a specific bug or a specific sensor just sends everything in Kelvin. So you need to change that into, let's say, Celsius. But here's the deal. You cannot change the sensor. So you need to change, you need to add a small bit of code. Here's the deal. This small bit of code is fine. You can just do that. And for the driver, even if you customize the ETAP driver, that's fine, right? But this happens with each unique problem. You're not gonna only fix one. You're not only gonna fix one problem, but you're gonna have more than one. Let's say that you're boiling water and you wanna make sure that you're at 100 degrees, but the machine reads 1,000 Kelvin. Oh, here's the deal. You can know what 1,000 Kelvin is, and that's all good and such, but the machine doesn't know what a Kelvin or a Celsius is. The machine only knows ones and zeros. You need to translate that Kelvin into Celsius because the program was written in line with Celsius or Fahrenheit, whatever you like to use. Here's the deal. After this, the human can still know that 1,000 Kelvin is this much Celsius, but the machine doesn't know that, and the machine is coded for that Celsius. So you need to change that, and obviously changing 1 or 2 is fine, but this happens with every unique problem that you have, and here's the deal. That would take a lot of time. While the customizing the ETAP driver for each unique device is proved time consuming. See, this time consuming is a real big problem because you're making a data center and the company doesn't want to wait. The company that is contracting you for this data center, they do not want to wait because why would anyone want to wait for something they paid for and something that they are going to use all the time? You're saying, okay, wait one more day. Okay, wait one more day. They might be losing money because of that one day. And you will lose money because of that one day because you told them, I'm going to get this done in 5 days. It's been 6 days. I'm still waiting. These issues are big problems that you need to think beforehand that you start creating these. You need to make sure you buy the sensor in Kelvin, in Celsius instead of Kelvin, so you don't run into this issue and you don't lose time. I said this as a metaphor, as a small example, so you can understand it better. But this is what it basically is saying. Let's see. Okay. This switch to Kepler. Due to strict deadlines commissioned by March 1st, the team abandoned the native ETAP Modbus driver in form of Kepler. They used the Kepler to aggregate SNMP and the Modbus data, fed it into ETAP via an OPC interface. See, here's the deal. The deadline, they had to change the native ETAP Modbus driver. Here's the deal. You could do this, but will this be good for this? Will this be useful? Will this have a problem? All of these changes makes it that you cannot just instantly change something. You need to think about all the other factors. And when you're in such a short timeline, you don't. Sometimes you just don't. Template consequences. Switching to OPC meant all data arrived as a massive list of registers and then discrete devices. This prevented them from using ATOP's device templates effectively, forcing them to manually map thousands of tags, which increased engineering time. Here's the deal. You thought you would get to the deadline faster, but in this case, obviously they got to the deadline, but they might have not. Because you just do this and you don't think about all of the tags, like if that program if that interface is as efficient as the one that was recommended by the ETAP Modbus driver, like it is its own driver, then you run into problems like this that could have been solved really easily with the other driver, but they're not, because you cannot. Sorry. All of these consequences, basically, it just means that you need to do a lot of thinking before you actually move on from, let's say, one interface to another. Visualization and user experience, HMI. Rovi's create two distinct viewing experiences based on user roles. Control room, TIC client, designed for operators, featuring a CID, a CAD driving background with a drill down navigations button. This allowed operators to click from the facility view down to specific gear and assets. Management, designed for IT and executives. This view focuses on KPIs, dashboards, and electrical schematics, as these users care more about facility performance and switching states. So it's basically saying control room is where all of the, let's say, electrical, mechanical, automation engineers look inside the place. Well, there won't be an automation engineer. You get the idea. Where all of these engineers, they need to look at the stuff and they need to see if there's a problem happening. All of the navigation buttons from the facility and specific gear and assets, how these assets are connected to each other, and if these gears are moving correctly. And if you need to move the gears correctly, you need to change their space and whatnot. Sorry, I'm just checking if the recording is still going on. That's why I'm checking. Management client, it's basically IT and executive. That just means we care about the performance in the sense that how well is this cooling agent performing? So can we up our efficiency? Can we up our production rate? Well, production, I give as an example because this is a data center. And how let's say, the switching states, as in, you need to, you don't need to change the switch, switch the states and whatnot. Like it says, ability, facility performance. This performance means you get more money. That's why the executives and IT care more about that, because they are more on the management side of things rather than just making sure the thing actually works. Thing can work. Thing doesn't have to make you money to work. That's why management and control room are basically different than each other. Obviously, the control room decides what's happening, even if it's less efficient. But if it meant that it has to be like this to work, then it has to be that way. Trending and alarm requirements. Massive trending. The client required every real-time point, around 5,000 tags, to be trendable. Typically, software only trends key parameters. Robbie's had to work with ETAP developers to enable trending for all attributes, which requires significant configuration effort. See, here's the deal with this. All of this, you want every real-time point tag to be trendable. That's the deal is you need to have so much work done. And like it said, they worked with ETAP developers, like the people who made this, they work with them to make sure they can actually get all of the attributes. Sorry, all of these attributes to be trendable, they needed to do so much work over this. And again, the company, the clients who wanted this, they required it. They didn't have to, but they wanted it. So you cannot say anything about this. Here's the deal. You need to work so much time over that. And the deal with that, why they needed ETAP developers and such, is because you might know really good how ETAP works and such, but I don't think you know it as well as the developers themselves. Notifications, email alarms were segmented by distribution lists. Mechanical alarms went into facility stuff, while IT alarms went to network admins. This is how the systemation of the stuff works. It's basically saying like this is how they were going, like how they were segmented and how they were listed differently than each other. And obviously they have to be different than each other because a mechanical engineer isn't going to do what an electrical engineer is going to do. Obviously, they need to do all of this. And and that's how basically they did it. And if I had to think that is a really specific point, then there's I would first of all the switch to Kepler is like this part is extremely important because before we come towards the end, I wanted to mention these specific points that I think that are more important than the rest. This switch to Kepler is really important because it shows you that you cannot just change it to eSCADA this easily. You cannot do this really fast, really easy. Everything works so smoothly. There always has to be a problem. And the deal is that's okay. The problems can happen. You need to have an open mind to fix a problem. And when you fix that problem, you need to understand what comes with that solution. In this case, the solution made it so that they had to let me read from here so I can explain it better. Meant all data arrived as a sorry, massive list of registers and then discrete devices. The OPC wasn't as easy to set up as the ETAP modbus driver as itself. Sorry. This native system that they didn't use was so much more simpler than the one that they passed to because it was for native itself. It was for the ETAP itself. But they changed into another interface, so they had to reassign all of the registers. And this caused them so much more effort. But it was a solution. It was a solution to the problem that we were going too slow. But it comes with a consequence when you do a solution. You need to keep that in mind. And key lessons learned. The sales power of modeling. The project was won largely because Rovies confirmed they could import the architect's existing electrical model directly into ETAP. This capability impressed the client enough to sign the contract immediately. See how they immediately said, we could already put all of this and import it right now. and that would be just fine. So the client didn't even think about it. They immediately went ahead and signed. The incomplete model trap. After reading the bit and importing the model, they realized the architect's model stopped at the main boards and didn't include the PD or racks. Robbers had to build the rest of the model themselves. Here's the deal. You accepted. You signed the contract. Here's the deal. The client signed the contract. That's fine. Oh my God. We won. But the problem is here. Maybe the model was incomplete. You do not know this. You just believe their word that it was complete. And if it's not complete, you have to deal with it. They had to build the rest of the model themselves. This was another problem that they overcome. You cannot guess how these problems might appear. Because they were implementing the eSCADA system, you never know how it can happen. IT delays. Critical information regarding the client's domain and network security was not provided until January with a March deadline, rushing the security configuration process. What if you leave an important part open? What if you leave a backdoor because you made a mistake? You leave that backdoor and everyone's information is gone. That's it. This is why all of these stuff is extremely important, especially the security parts are really important. You leave a backdoor and everything is hackable and it's all over. Your company will never recover from that. Future path. Scaling up. While this project had 5,000 tags, Service is looking at clients with 1 million tags, handling the storage and retrieval of 3 years of historical data. For that, many points is a major upcoming challenge. Utilization. They are currently utilizing only about 2% of ETAP's capabilities. The goal is to move beyond just monitoring and start using the predictive and analytical features of the software as they get more comfortable. It's saying how as they learn it more and more because of the native software and the interface they were using, how they are not utilizing anything. Basically, 2% is nothing. They are not utilizing anything. How they want to utilize more of that and actually use the predictive and analytical features. So you will not have to worry about anything as the analytical and the predictive features means, let's say during Halloween or during New Year, since we're really close by, during New Year, people will use the television more. People will buy a lot more tickets to the New Year Eve contribution. Well, that's the thing in Turkey anyway. Or hope people will buy so many more stuff on the internet because there are more sales. You need to think about all of these and you need to take your load. I'm not giving an example upon this video. I'm just giving an example in general to make you understand how these features move along and how they can actually implement and use them. And they need to understand more of it to use it more. But that was basically it. For me, there is nothing more I can tell you about this. If you wanna ask me something or ask about the video, you will obviously find it in the description. And if you need anything, you can tell me in the comments. And as always, have a good night.